Alright, so I'm going to start by drawing out the normal distribution that describes this um, variable we have in the question. So we have the length of a trial in days as our outcome of interest. We have a mean of 4.2 days and a standard deviation of 0.9 days. So this tells us that for any particular trial, the most likely length is about 4.2 days. It's unlikely that it's going to be much shorter, unlikely that it's going to be much longer. The first couple of questions on the slides ask you to apply the 68, 95, and 99/7 rule. To do this, we can mark off the 1, 2, and 3 standard deviation jumps away from the mean, which I'm doing with these tick marks. So our standard deviation here is 0.9, and we're going to fill in these tick marks by adding 0.9 for each one in this direction and subtracting 0.9 for each one in this direction. If we do that, we get 5.1, 6.0, and 6.9. So plus 0.9, plus 0.9, plus 0.9. Going in the other direction, so subtracting, we'll subtract 0.9 from 4.2 to get 3.3, 2.4, and 1.5. So the first question asks you, what's the probability that a trial is going to last between 3.3 and 5.1 days? We can see we've got these numbers already written out here as our tick marks. And so the 68, 95, 99/7 rule is going to let us find a probability for getting an outcome between these two numbers. And specifically, it tells us the following things. Within one standard deviation of the mean on either side, we find 68% of our area under the curve, which corresponds to a 68% chance of getting an outcome within one standard deviation on either side. Within two standard deviations on either side, we've got 95% of our area under the curve, or a chance of 95% of getting an outcome between the corresponding values. And for three standard deviations, we've got 99.7% of our area under the curve. So the first part of the question asks you, what's the probability that a trial is going to last between 3.3 and 5.1 days? We can recognize these values on the x-axis. These are our +1 and -1 standard deviation jumps away from our mean of 4.2. Because we know that area under the curve is equal to the probability of getting an outcome between two values, we know that the shaded area here is going to be equal to our probability of getting an outcome between 3.3 and 5.1 days. The rule tells us, without having to calculate anything or use the z-table or anything like that, that we're going to find 68% of the area under the curve within the mean and one standard deviation on either side. So that means that the shaded area here is 68%. Again, we don't have to calculate anything. We know this because of the rule, and all we had to do is fill in these tick marks here to see what are the values that are at plus and minus one standard deviation away from the mean. So our rule says that we have a 68% chance that the trial is going to last between 3.3 and 5.1 days. The second part of this question asks you to fill in the range of values, so the range of days, where you've got a 95% chance that a trial is going to last between that many days. Our 68, 95, 99/7 rule, we've got two other probabilities to work with here. One of them is 95. And so the rule tells us that we're going to find this range if we look for the mean and plus or minus two standard deviations on either side. Well, our two standard deviation jumps away on either side. We're at 6.0 and 2.4. So we jumped out 1, 2 standard deviations to get to 6.0, 1, 2 standard deviations to get to 2.4. The 68, 95, 99/7 rule tells us that we're going to find 95% of our area under the curve within two standard deviations of the mean on either side. So applying this rule, we can say we have a 95% chance that a trial is going to last between 2.4 and 6.0 days. So our answer to the question is that we can fill in those blanks with 2.4 and 6.0. We have a 95% chance that our trial is going to last between 2.4 and 6.0 days. And I didn't ask you this in the question, but I'll just fill it in for the sake of completeness. If we apply this last part of the rule, we can say we've got a 99.7% chance that our trial is going to last between 1.5 and 6.9 days. Because now we've got this area under the curve within 3 standard deviations of the mean on either side, corresponding to the area under the curve between 1.5 and 6.9. And that means that we can be 99.7% sure that a trial is going to last between 1.5 and 6.9 days. All right, the second part of the question asks you to find the probability that a trial is going to last between 3 and 7 days. So I'm just going to redraw this distribution since this one got a little bit messy with all the other stuff I drew on it. We've still got our mean of 4.2 and our standard deviation of 0.9. And now we've got 2 other things to draw in here. Putting a line at 3 days and a line at 7 days. And our units on the x-axis are still days. So knowing what we know about area under the curve and probability, we know that the answer to our question is going to correspond to this total shaded area under the curve. In other words, the area under the curve between 3 days and 7 days is going to be equal to the probability of getting an outcome between 3 and 7 days, which is what we're looking for. And we can answer this question by completing the 2 steps that are built into the question. The first one is to find z-scores. So we can find z-scores for our values of 3 and 7 using the z-score equation, where z is equal to x, or some value of interest, minus mu, or the mean, divided by the standard deviation. And so in this case, we can find z-scores for 3 and 7 by plugging in these values for each one. So for 3, z is going to be equal to 3, our value of interest, minus 4.2, our mean, divided by 0.9, our standard deviation. And that gives us negative 1.2 over 0.9, and that comes out to negative 1.33. For 7, everything's going to be the same except we're plugging in a 7 here for x instead of 3. So we've got 7 minus 4.2 over 0.9. So that's going to be 2.8 over 0.9. And that comes out to 3.11. So these are our z-scores, the first part of the question. We can then use these z-scores to find the probability of a trial lasting between 3 and 7 days by converting our normal distribution to a standard normal distribution. And if you recall from last week, a standard normal distribution always has the exact same characteristics. It always has a mean of 0 and a standard deviation of 1, and the units that we're counting in are z-scores. And any variable can be converted into z-scores. When we do that, nothing about the distribution changes except the units that we're counting in. So we're going to have our lines in the same place. We can fill in these z-scores, so 3.11 and negative 1.33, and shade the area between them. And once we've done this, we've converted everything to z-scores, so we're no longer counting in days, we're counting in z-scores now. But every single thing about these 2 distributions is the same otherwise. They're the same shape, they've got the lines drawn in the same places, and they have the same area shaded underneath the curve. Once we have this standard normal distribution, we can look up these shaded areas using that handy-dandy z-table that we met last week. So the z-table, if you recall, shows the area under the curve between the mean and various z-scores. If we take a look at this distribution here, we can see we have 2 areas that fit that description. So we've got this one here, this is the area between the mean and a z-score of 3.11. And we've got this one over here, which is the area between the mean and a z-score of negative 1.33. So what we're going to do is we're going to look up these areas on the table, and since these 2 distributions are exactly the same in every way except the units we're counting in, this area is going to be exactly equal to this area, and this area is going to be exactly equal to this area over here. So whatever we find in our standard normal distribution, we're going to be able to fill in here in our normal distribution where we're counting in days. So to use the z-table, we're going to use our z-scores. And we'll start with 3.11 here. So the area under the curve between 0 and a z-score of 3.11, in other words, the area under the curve on this positive or right side of our graph here, on the right side of the mean, we'll find by looking up 3.1 going down this column and at 0.01 going along the row here. So 3.1, it's hard to see, is down here. 0.1 is here, and we can find where they meet to get our area. So these two intersect at 0.4991, and that tells us that our area under the curve between our mean and our z-score of 3.11 is 0.4991. It also tells us that our area under the curve between 4.2 days and 7 days is 0.4991. Because again, these two graphs are exactly the same in every way, except that in this one we're counting in days, and this one we're counting in z-scores. We can also find the area under the curve between 0 and a z-score of negative 1.33 using this chart. For this, you can ignore the negative sign. And here we're going to look at 1.3 going down the column. And our 3 tells us to look at 0.03 going along this row for the hundredths plates. And we'll see where they intersect. The area under the curve between a mean and a z-score of negative 1.33 is 0.4082. So we can fill this in as well. Because these two are exactly the same in every single way except for the units we're counting in, this area between under the curve between 3 days and 4.2 days is also equal to 0.4082. So we're almost there now. We know the probability of a trial lasting between 3 days and 4.2 days is 40.82%, or 0.4082. We know that the probability of a trial lasting between 4.2 days and 7 days is 49.91%, or 0.4991. But we want to know the probability of a 3 to 7 day trial. To do this, we're just going to add these two probabilities together. So the total area under the curve between 3 and 7 can be found if we add the area under the curve on this side of the mean to the area under the curve on this side of the mean. And so we get 0.4082 plus 0.4991, and that total area under the curve is going to be 0.9073. So we can answer our question, what's the probability that a trial is going to last between 3 and 7 days, and say that we've got a 90.73% chance, or a probability of 0.9073, that our jury trial is going to last from 3 to 7 days. And so that finishes our recap of the activity. From here, we're going to go into the material for this week, where again, we're going to be focused on sampling and sampling distributions, and we're going to be talking about how to use what we've learned about probability so far, what we know about normal distributions so far, to start learning about populations from samples.